Hello everyone, it's Christopher and I'm back with another episode of the Func Prog podcast. I've been on vacation, so I'm releasing this episode a bit later than usual. I'm sorry about that. But after the vacation is over, I will go back to our regular bi-weekly scheduled programming. And this episode I'm talking with Eric Torreborre about a bunch of things, but most notably the Unison programming language, which is a new and exciting way to think about, well, a bunch of things: concurrency, RPC, even how you write programs, etc. Before we start, I would just like to give you a tip. Like, if you're into Scala and you're listening from the Stockholm area, or are willing to travel, we're having a Scala event in the Scala Stockholm MeetUp group on the 18th of August, and we'll have a special guest coming as well. If you want to go to the meetup, head over to meetup.com and search for Scala Stockholm and you will find it. Also, there's still seats left for the Func Prog Conf, the first of hopefully a series of conferences about functional programming here in Stockholm. That's on October 15th, and you can find tickets and more information at funcprogconf.com. And the links, I'll put links to both of these events in the show notes. But without further ado, here is my interview with Eric Torreborre. Eric, who are you?
Well, I'm just a software engineer that has a passion and at least a very large interest into functional programming. So, and in general, like development of reliable software for innovative products.
Okay, innovative products. And I think today, one thing I would really like to talk with you about today is the Unison programming language.
Yes.
Because you have been experimenting with Unison quite a bit, right?
Mm-hmm, true.
I also saw that you have contributed to the Unison codebase.
A little bit, yes.
Yeah, it was some cryptographic stuff, right?
Yes, yeah, actually I needed that for my own stuff, and there were some cryptographic primitives that did not exist at the time. I think it was the ED 25519 signatures were missing. And,
okay.
But they exist in the Haskell library, so it was just a matter of exposing them for the Unison code base.
Okay. So it's just because Unison is written in Haskell, right?
Yes. And a bunch of Unison primitives map directly to some Haskell counterparts.
Okay, so basically you could expose the Haskell cryptographic primitives to Unison and it just worked, basically. Yeah, but okay, so if we zoom out a little bit, what is Unison?
Yeah, so Unison is a functional programming language with static types that looks pretty much like Haskell in many ways. The syntax is very reminiscent of Haskell. It's also a much simpler language than Haskell. So you don't have extensions, for example, in Unison. The record system is a bit simpler as well. The module system, you don't have privacy modifiers. For example, you cannot say this function is public, this one is private. There are no type classes. So it's a much simpler language than Haskell, but it has two important properties that really set it apart from something like Haskell. The first one is that all the code that you write some text gets serialized as an AST, and once it's compiled, when it's valid, it goes to a database. And that has strong implications on the development of everything you do. So on the development cycle, on the deployment, and so on. And also, one big consequence is that those terms, once they are compiled, they are hashed. And what represents them is the hash of all the content. And it's not really the name of the function you create. So that means that you can evolve the code pretty seamlessly because all the dependencies are not through names, but are through hashes. So that's a very important thing. And the second thing is that instead of using monads to control effects, it's using an effect and type system with handlers that is heavily inspired from a previous language that was a research language called Franc, but that's also reminiscent of languages like Coca or Effect with a K in Scala. I mean, Effect is not in Scala. I think it's implemented with Scala, but it's its own language. And yeah, and that's another way of dealing with effects. So there's no IO monad, there's an IO effect, for example.
Yeah, it seems like quite a lot of things to take in.
Yes. Well, I mean, those are really the two major things about the language. The rest is like simple functions, simple data types, and it's quite simple to understand. You don't have so many rules and gotchas. Yeah.
Yeah, and it's like if we start from the beginning,
Yeah.
I think what really, I think what most people will see first, or like, the main difference that they will notice is that you don't really work with files
Yes.
in Unison.
Yes, that's very troubling at first. Like you're thinking, where is my code? Where? And then okay, it's actually in a database. So if you want a function, you call edit, that brings that function into a file, but you don't even have to name that file. It's called, the default file is named scratch.u, and that is used by default. And then that once the code is saved into the database, you can just get rid of the file. So I think different Unison developers have different ways of handling those files. I think Runar, one of the developers, he piles up thousands of lines of code into the same file, and then eventually restarts a new file. Because one thing I did not mention is that there's a super command called a fold, like 3 dashes, comment everything that comes under the dashes in a file. So if you want to edit something new, and in some processes, everything will be commented out with 3 dashes, and then the new code will appear on top.
Okay. So it's like it sort of keeps track of what the code that you have saved already, and then okay, I see.
And at first, that made me quite uncomfortable, coming from text file management, and also you don't necessarily have all the support that you have in a normal IDE for following methods, clicking on something, opening a new file where that thing lives, because now it's just something else in the database, actually.
And for example, is there like, I know there's a VS Code extension for Unison, but does this help you with this? Like the thing that you said, automatically commenting out things that have already been...
So I think so. There is a VS Code extension which is using the LSP machinery language server processor. Was it no language server?
Language server protocol. So
protocol. Thank you.
Yeah.
Yes. And I think that could be better. I think the whole IDE experience could definitely be better. So in general, you have your screen is divided into two smaller screens, one for the editor and one for the so-called UCM manager, the code manager, where you can have all the commands to find some code, to edit some code, to rename terms, to list your libraries, to install other libraries, do things like this. And you really have those two parts. But I think it would be better if you had a lot more windows.
Okay.
One to display the docs, one to display your test, one to display your compilation errors. But there's one person on the Unison team that's really responsible for all this tooling, and he's currently working on a new IDE.
Oh, okay.
Yeah.
So it's like a Unison specific IDE, or...
Yes, it will be Unison specific. Yeah.
Interesting. Very, very cool. But what was I thinking about? Yeah, so the I guess that sort of has a pretty heavy impact on your workflow, right? Like the fact that you don't have have files. But on the other hand, it sort of reminds me of how Emacs works as well. Like, because if you're an Emacs user, this might not seem that strange to you, because usually when you write like Emacs Lisp to customize Emacs, you usually do this thing where you write some commands in a scratch buffer, and then you sort of like, or I guess this is sort of the Lisp, the whole Lisp REPL-driven development experience actually taken to its logical extreme.
Yeah, yeah. It has. I think it also has one thing that's interesting in terms of your how you approach the code in your own development. It kind of forcing you to focus on a single thing at a time. Like now you're working on one function or like a bunch of related functions and data types. Once you're done with this, okay, you go and do something else, which I think it has an interesting focusing aspect to it.
So and how does it work? Like, you know, you want to you say something like, you know, okay, I want to edit this function, and then it can sort of like spit out the current definition of that function, and then you sort of hack away. Is that how it works?
Yeah, yeah. So that's how it works. And if you make modifications, for example, in the function signature, that's going to have an impact on something else that was depending on that function, then when you update, it will detect that, okay, maybe that function compiles perfectly on its own, but then now you're triggering other compilation errors. So it will bring all the code that depends on that function that might be broken into your editor, and then you can hack away and fix those errors. There's a new feature that just came out the previous week where now it's also creating a branch for you. So
okay.
if there are issues, now you will work on a specific branch to just fix that, and when everything is clear, the branch is automatically merged. Which is a really cool feature. Yeah.
Yeah. So I saw a demo of this as well, and it's really nice because it's like in most IDEs, when you have a bunch of compilation errors, you sort of have to walk through those by hand anyway. Like, you know, let's say I try to compile something and I get 10 errors. I'm like, oh, okay. Then I go fix them one by one. But in this case, it's like, you know, oh, you try to change this thing. That means you have to change all of these other things as well. So, and then you get all of them back in your editor. I thought that was quite neat, actually.
Yeah. Yes. Yes.
And is this like, sorry?
Yeah. The only thing that I regret is that by default right now, you only get one compilation error at a time. And sometimes I wish that I had all of them in a small window where I could see at one glance, okay, how many issues am I creating by just making that one change?
I see.
That would be nice to have.
Yeah. And like every time you change like something in the like, let's say I change a bunch of different definitions at the same time, can I do that? Is that like, I guess that's my first question. Is it possible to change like several definitions at the same time?
Yes, absolutely.
And then that gets like atomically committed to the...
Yeah, exactly. Yeah. So one huge consequence of all of this is that once the code is in the database, it's always correct. It's always type checked. You know that this code is in a good state.
Yeah, and so like, okay, so it's only compiled. If it doesn't build, it doesn't go in the code base, the database, or code base database.
It's an actual database. It's backed by SQLite. Yeah.
Okay. And how does that work? Like you mentioned something with branches earlier. Do you have like individual like commits, or what you want to call it, like, so you can go back to a previous snapshot of the...
This is excellent question. So we don't have yet commits. It's on a roadmap. So you can create branches, and then you can navigate your branches and merge branches and go back to the main branch and merge the feature branch, for example. But you have something called a ref log, a bit like Git. Ref log in Git, and you can navigate and see all your changes. But at the moment you cannot name them. You can see what was the main command that led to that new log in the log entry. But you cannot. So you can come back in time to a previous action, but you have to kind of remember what was that update about. And
I see.
That's, for now, it's a bit complicated.
Yeah. Yeah, I guess like being able to like tag things
Yes.
could be helpful in
Yeah.
the future.
Yeah, that's coming. I
Okay.
think the roadmap. If you go to the website, you will see there's a roadmap divided in several sections, like something like very soon, soonish, and maybe. So, I don't remember the name of the exact names of the sections, but this one is really coming soon. Yeah.
Okay, yeah. It feels like we're getting a lot of like really hot news here on the podcast, like
True.
very latest Unison updates. But something that was thinking about like regarding the workflow, I mean, if we're continuing along like the Git or like VCS analogy, do you also pull changes from like a central
Sure.
database?
Yes.
I guess to get the latest code. And and I guess that also means that if you push code to the like central database, you can get conflicts as well, or how does that work?
Actually, no, because so you can always create branches and you can pull from branches and push to branches, but your branches are always private. So they are tied to your user. So everything you push just overrides what you did before. And then if you want to merge with something else or merge to, if that's a contribution to a project, then you might have conflicts that you have to solve yourself before merging.
Okay, but so the process is that you sort of pull out the latest changes, and then you like make the update, and then you like, sort of try to merge or consolidate
Yes.
your branch, and
Yes.
then you push. Okay, yeah. I mean, I think that the and we haven't really touched on that, but this is all based on the fact that all Unison code, like you said, it's encoded as what would you call it? Like a parse or as like a syntax,
Yeah, it's a syntax tree.
abstract
It's an
syntax tree,
AST. Yeah, exactly. Yeah, yeah.
and then each node is hashed, right? Or I guess the functions can be identified
Yes.
with hashes.
Yeah, so you have functions and data types identified as hashes. Yes.
And I think so. When I've been reading about Unison, I think one thing that sounded quite cool is that you can sort of upgrade the Unison code base live without having to like turn the whole thing off and on again, because like old code that's still running
Yes.
will not automatically refer to the new names of things. It's like
Yes.
it's just, I mean, names are just aliases for hashes, and then I think, or do they get replaced like when you compile the code, or how?
Yeah, so if you update something locally, then the name of your function gets committed with a different hash, because if it's that's a different code. Yes. So that's the case. You can also have aliases on functions. You can say, I want my function to be named foo, but also blah, and that will work. And you can see the different aliases. I mean, some people have their preferred terminology for functional programming, so that's a perfectly acceptable way of doing things. But otherwise, yeah, when you update something, this is where you assign a different hash to the same name. Yeah.
Yeah, I think that, and I mean, there are a lot of cool things that you can do that, like this unlocks, right? But I think we can get into those later. But what would you say is like like if you compare to like the regular old files and repos, way of working, what would you say are some like pros and cons compared with the Unison way of having like a code base as a database?
Yeah. So I think there are many, many pros. Obviously, the idea that the code is kind of immutable. Once you've written something, that thing will never change. So you can depend on it all the time. And I can push some new code, but that doesn't matter because you will only depend on that hash. That is super important for any kind of stability of your systems. That is fantastic. The cons are one con maybe is more about in a way a marketing con, or like if you see how a language can evolve and develop and get developers and so on. One difficulty is that because it's not text based, you cannot use GitHub. So at first, the team originally was using GitHub to share projects, but they were like blobs. You put a blob of things on GitHub. It's just GitHub becomes really unusable. So
just a SQLite database dump.
You can imagine. So this is how they decided to implement their own GitHub thing called Unison Share to share projects amongst people. But then if you think about GitHub, there are so many things tied to GitHub. So many plugins, there's issue management, discussions, whatever you have, GitHub actions and so on. So you have to reinvent all of this for your language.
Yeah, that's true. There's a lot of like workflow things that you sort of lose, I guess, and that you have to sort of build up again from scratch.
Exactly.
But and like you said, it's I guess the adoption thing is quite like it's going to be challenging, I think, because I mean it's once you tell people that like you don't get to have files anymore. I guess most people sort of think that's kind of weird. Like most people will not say, "Oh yeah, no, just like small talk then." Like,
exactly.
No big deal.
The adoption in that sense is so. First, it's a functional programming language. It has an effect system. It has no files. So for many people, it's completely alien. Yeah.
Yeah, but on the other hand, I think it's sort of like the reason I'm excited about Unison is that it feels like it gets a lot of things right. And I think to be completely honest, I think we are in kind of a bit of a mess right now when it comes to programming in general. And especially things like, the things that most people do in their everyday work, just like regular business systems.
Yes.
Where you basically get data out of a database, you process it somehow, and then you put it back in. And that thing, it sounds very simple. Like, it sounds like it shouldn't be that complicated, right?
Yeah.
But still, somehow, we have managed to make it very complicated. And it feels like Unison probably has answers to some of those questions. Like, why is it so complicated and what can we do differently?
I think, partially one reason why we are in that mess is because in a way, that's the Unix mentality that everything is some text that you can pipe around to different programming languages that know how to interpret that text. And Unison really tries to remove all this friction of having to reinterpret things so many times. So, for example, when you deploy Unison services, you don't have to put things into JSON and back to Unison again. You can just serialize the whole Unison terms. And even better, those terms can be functions. You can serialize functions and send them over the wire, and that just works. When you want to persist things, Unison Cloud has its own persistence primitives as like logical tables, and then you can persist your terms. You don't have to translate them to some table format with some columns that have different types that you need to know how to map to your programming language, and the devil is in the details for those kind of things. You just store things. You say, now persist this piece of data, and that's done.
Yeah. I mean, that sounds really, like there's a lot of interesting stuff you said here, I think. And like, I mean, because like this kind of things, like, I mean, it feels like we have a bunch of bugbears in traditional software development, and that's like, deployment and CI, that's one thing. And then like, serialization and deserialization, which is always a chore. It's doesn't add any value whatsoever. and then also like the classic impedance mismatch between database and the code. But you are saying that Unison can get rid of all of these. It sounds too good to be true, almost.
Uh, it is as good as I'm saying it is. I think it can be perfected in many ways, but because they are relying on strong fundamentals, I have great hope that we are going to get really a great development environment.
But if we start from the first thing, like one thing you mentioned before is that like when you like push code to the Unison database, I mean you just push basically your updates. So how does it work when you deploy Unison code?
Yes. So I need to mention a few things. So first of all, one thing I love is the idea that you can write some code and you can deploy it using Unison code itself. You don't have to use some YAML file describing where your machines are, which container they need to use, and so on and so forth. You just use some code to deploy some code, which I think is fantastic. Just as an aside, the first time I saw that in a Terraform file, you had something called a var as a piece of YAML describing effectively a variable where you wanted to hold some value. I thought, but that's a programming language encoded in YAML. That's really silly. We should not do this. We should use a proper programming language to do those things.
Yeah, there's so many programming horrors related to that. I think, like having your own like bespoke domain-specific language that like implemented in YAML. But yes, sorry, go on. Like in Unison, you can use Unison code.
So you describe your service. You say, okay, this is my service. It has, for example, it has an HTTP API with a bunch of routes that can accept some values and that do some stuff and then persist some data, classical stuff. And you give it a name. And the first time you push it, all the code gets serialized, goes to a machine, and it's tied to a bunch of routes. And the service has a name, so you have a unique function accepting values. It's well typed, and you can then call that service from another piece of Unison code, and you know that everything will communicate perfectly. And then what happens is that you can still push new code and deploy the next version of your thing, and then you can have that function be called. The first function can be called function v1. The second will be function v2. And when you're ready, you decide that your service that has the name service will go to function v2 instead of function v1. And this is how you decide to switch your deployment from an old version to a new version. But you can also leave the old endpoint open for all users. You're just accumulating code every time you do a new deployment. You're not removing or replacing any existing code. Everything is really immutable.
I think the cool thing is as well, like since everything is based on this content address hash thing, like let's say your complete code base is like 50 megabytes. If you push a change, that's not another additional 50 megabytes. It's just like the delta of the old and the new version. So I think that is really cool. But how does it work with like distribution, for example? If let's say I want to have like 3 application servers running or something, like is there a way for like the Unison runtime to control that, or how does that work? Like where I'm trying to figure out like what is there some kind of like orchestration between servers that decides how the application should run, or
so first thing, this is not the domain I know the most because I have deployed a prototype service a few months ago, but then that's it. So I'm not as proficient on that part of the system. But as far as I know, the nodes are being deployed with the code as necessary to scale it, and the Unison runtime takes care of this. And it also does something that's quite magical, is that if it sees that two services are communicating frequently and they are deployed on different nodes, it actually can move the code from one node to the other. So then suddenly all the codes, all the calls become local.
Oh, that's crazy.
Yes, and that is really cool. So Paul Cusano, the CEO of Unison, has written a LinkedIn blog post about it, explaining how I think it's called adaptive calls, or I don't remember the service graph calls, something like this.
Okay. Yeah, I will have to link to that in the show notes because
Yes.
that sounds really really advanced. And just to clarify, like this thing, like it's not a proprietary thing. This like Unison runtime, distributed runtime thing. It's something you can run on your own hardware as well, right?
Yes, yes. So there are two offers. There's Unison Cloud where you can subscribe and get. There are different plans where you can get different amounts of computing power and memory. And then there's Bring Your Own Cloud where you can take all the software as a package, install it on your machines, and run it by yourself. Yeah.
Yeah, that's so it's like there's no. I mean, I guess the vision is that they will make money from Unison Cloud, but you can still run it on your own hardware. So there's no there's no hard vendor lock-in.
Yes. Yes.
But I mean, I think kind of the selling point for this is that I mean, okay, so first of all, Unison sounds like it can help you get rid of a lot of infrastructure boilerplate. So then why wouldn't you want to outsource the whole thing? Like, it makes a lot of sense, I think. But one thing I was also curious about. So let's say I'm hacking away on my local machine, and then I want to push some stuff to production. Like, what is would you then push your changes direct from your local Unison database to the production database, or how is there some staging process there where you first deploy it on a CI server or something like that, or maybe that's not even necessary with the maybe you're confident enough just to push things straight to.
So there's one first thing is that before deploying anything, you can test everything locally. So we haven't talked so much about abilities, but abilities are this mechanism in Unison where you can declare a bunch of functions that get later on handled by an interpreter that gives them some meaning. So, for example, a store ability will give you the possibility to store some value into a logical memory cell and then retrieve it later. That's the store ability. And there's a cloud ability that actually no, it's called remote ability that defines everything you can do with remote code that can be deployed. And there are actually two handlers for this remote ability. One is used in production on the servers, and one can be used locally.
Okay.
So you can run all your code that's supposed to be deployed. You can run it locally on your local machine, test that everything is working correctly before being deployed. So that's one first step that you can take to make sure that everything will probably work okay. And then when you deploy your service, you don't have to bind it right away to the production name of that service. You can bind it to a name that's called staging, and then you can call that staging name first, make sure that everything works okay, and then just do the switch between staging and production.
Okay. So there's you can have some kind of
Yes.
what do you call it, like CI/CD pipeline, but I guess it's a lot less work when the infrastructure is more abstracted away. One thing that I found quite interesting, especially as someone who is used to working with statically typed functional programming languages and just staring at the compiler, waiting for it to finish is that
Mhm.
I understand that the Unison compile times are also quite good.
So far, so good,
Yeah.
but I managed to find one or two occasions where it was taking some time.
Okay.
So one situation was me playing with abilities,
Mm.
and once you start having list of a lot of abilities, and I'm talking about like 100,
Oh, okay.
which
Oh,
is
yeah.
very
Yeah.
very unusual. Then the compiler takes forever.
Mm.
That's one thing. But I mean, it might be for a silly reason. Might be because I mean, no one is really supposed to use that many abilities, and maybe things are not optimized for this. That's one possibility.
Mm.
But more recently, in one of my libraries, I created like a bunch of functions that would look very similar, but they were like maybe 10 or 15 functions.
Mm.
And the compiler was really slowing down. And
Okay.
I don't know why yet. I haven't investigated that yet. But most of the time, it's quite good.
Mm. Because I guess like one thing with Unison is that it can reuse a bunch of type checking results, right?
Yes.
Because like it knows since there's no like I think the more you think about this thing where you have like separate like like getting rid of files is that if you think about it, like the files and the code is actually like multiple sources of truth.
Mm-hmm.
And it feels like a common thing that makes compilation slow is that like you have to sort of consolidate the files on disk with
Yeah.
the what's in the compiler. So even if you cache results from previous compilations, you still don't. You still have to recheck a bunch of stuff every time,
Yes.
just to make sure that like nothing else has changed in the files. But I mean, yeah, with
Yeah.
Unison you don't have that problem.
You really have like perfect incremental compilation in that case, which is
Mm.
great. And that's not as obvious as it seems, by the way, because if you think about how you should hash recursive functions, two different functions calling each other, how do you even hash them? Because their definition depend on the other definition.
Yeah,
So,
that's a good question.
there's a special scheme in Unison to make sure that this works.
Mm. Yeah, it's like it sounds like a hard problem.
Mm.
But you were talking about abilities. Maybe we can dive into that a bit. Like, so
Sure.
you mentioned that abilities. It's a way to handle like side effects in
Yes.
Unison. I guess. But, can you expand on that?
Yeah, so yeah, maybe I will just call them effects because
Mm?
side effects is typically the thing that we want to avoid.
Mm.
We don't want things to be on the side. We want things to be front and center in a way to really control them. So first of all, I think that's the future for functional programming languages. So I've used Scala and Haskell pretty intensively, really in functional programming settings, where you use monads to control effects. I mean, things that can happen while you do your computations. So for example, keeping track of some state,
Mm.
doing some I/O, getting values from some configuration, and then depending on that value to do your stuff, doing non-determinism. I mean, there are all sorts of monads to help you do those things. And in general, the notation is pretty involved. Sometimes the code look very different from other code that does not use those effects. The function names can be different. So you talked about having map and map m
Mm.
previously, and those are different functions. One is with effect, the other one without effects.
Yeah,
And
yeah, you have to like. There's a lot of things you have to do double work for because one is like works on just regular code without side effects, and then you have to do special cases for when you
yes,
have monads.
and then there's the thing about monad not composing together.
Mm.
The two monads, one into the other, might not make an overall monad. So this is complicated. And I see that, I mean, we have a proof that there's another way of doing it, which is called a direct style sometimes, where you
Mm.
can just call something. It might have an effect, but that effect will be tracked in the type system. So it's like integrated into the language. and then we can handle this effect. We can say this effect takes place from this part of the code to that part of the code, and I know what to do with it. And so what does it look like in Unison? So it's called an ability. And an ability definition is a bit like an interface. You give it a name. So let's say, for example, the read ability that will give you a value coming from a piece of configuration. So you want to have your code depending on a specific value that will be provided later, and you want to be able to ask for this value. So the read ability will have this ask function that says, okay, I can provide you this value whenever you need it. So you write your code, and inside your code you write ask, and you continue writing the rest of the code.
Okay, so and that could be, for example, if I have like a config file, I might have stored like, okay, what is the address of my SQL database, for example?
Exactly right. And now that piece of code that uses the ask ability, that function where you put it, will not be a simple computation because it needs something else to work. So in the type of the function, there will be some curly braces showing that you need the read ability to be able to run that thing. And later on, when you want to run that thing, you need a so-called handler, which is a function that will take this code and know what to do. When someone asks for something, it will know how to interpret it. It will have to provide a value, and the handler has access to the continuation of the code. So it has access to the rest of the code to execute, and it says, okay, take the continuation, give it a value, and now we know how to proceed with the rest of the code.
And the I guess the cool thing with this is that I mean, one way you can provide like one way to handle this is to provide a handler yourself in the code, right? So it's sort of like if you I mean, if the listener is familiar with the classic try-catch mechanism, this would be equivalent to, you know, having something throwing an exception and then you catch it.
Exactly.
So, like I guess in this case, you could, for example, if you're writing a test, you could actually manually inject config values, for example, as part of the test code.
And I think this is what made, I think this is also what makes a language like Rust successful, for example. The fact that you have abilities in Rust in the form of error management with the question mark, where you say this function can throw a result, and the language handles this for you. The same thing for async. And async and error management are like super important to use. You really need those things. But in Rust, they baked it into the language. They have their own syntax. It's part of the language. In Unison, you can have async and error management as library code. Because the effect system is generalized, and you can create your own effects, and you can handle whatever existing effects in a different way if you want to.
Because there are a bunch of effects or just to clarify something, like if you don't handle an effect manually, then it will be handled by the runtime, right?
I mean, yes and no. If you don't handle something manually, if you create your own effect, and then the runtime will tell you, I don't know how to run this code. I need a handler for it. Unless it is something that the runtime knows, which is something like I/O. If you use the I/O effect, this is provided by the language. The runtime knows how to do some I/O, and if you write a main function that has some I/O code, it will know how to execute that. Yeah.
And I guess I mean, if we take like a step, like a more like philosophical approach, like why would you want to do this at all? Like compared to, for example, just having what I guess the opposite would be, like completely like unmanaged I/O, just having like no control over the effects at all, like I don't know, C# or something like that.
Well, because you get a lot more control over what your code is doing and what your code is not doing. I mean, you probably know in Java, the equal operator on the URL class, what it does. does DNS resolution to check if two URLs are equal.
Yes.
So you write some very innocent looking code, and then all of a sudden there's a network fault, which is crazy.
Yeah.
Right?
So like, that part is really funny. Like you can actually break your Java code, even if it doesn't doesn't look at all like it's going to access the internet. Like, if you do it on the train, for example, your code suddenly won't work
Yeah,
because it's
exactly. Why? So yeah, we want to avoid those kinds of surprises.
yeah.
Yes.
I just I'm grateful to the the JDK authors, because that's a very good example, good motivating example for why you would want to have.
Exactly.
Yeah, no, but I agree. Just trying to play devil's advocate here, and I think it's funny in a way that a lot of the things that the functional programming people have been advocating for from the beginning, like with the theoretical motivation. For example, since Haskell is lazy, it's really good to have you sort of need a principled
Yes.
approach to side effects, because otherwise things might execute out of order, and then that's how you ended up with monadic IO, for example. But it feels like a lot of the imperative or the procedural programming community has sort of arrived at the same conclusions, but with different motivations. For example, if we go back to C#, they don't really like completely lawless or just Wild West use of side effects either, but then they use dependency injection instead.
So I have a big rant about that.
Yeah. Oh yeah, I saw your Lambda days, your
Yes.
presentation.
Yes. And I think one issue I see, so in Haskell, you probably know that there are many effect libraries in Haskell. They try different approaches how to design this and allow higher order effects and things like this. And I think one sometimes effects, the way they are presented as a way to design components. So because an effect looks a bit like an interface with some functions, a handler look a bit like an implementation for that thing.
Yeah.
So you're thinking maybe I should design all my system around effects because I have the notion of interface implementation, and then I can design my database access. I can design my payment system interface and things like this, or email service.
Yeah.
And I think it's totally the wrong way to do it because in general, handlers, they are not really flexible for doing any kind of dependency injection. We need other ways of dealing with being able to inject exactly the right thing at the right place is in general not supported by FX systems. Be them effect libraries, abilities, type classes, they are not the right answer to that problem. Those things are very good at things like having a state monad, threading states across code so that it's transparent, threading configuration, dealing with database transactions, dealing with non-determinism, things where you absolutely need to access the continuation of your code. But everything that is well contained with an interface and in an implementation can just be called directly. You can just pass it around. You don't need an effect system to do this.
So it's like you wouldn't recommend, for example, if you contrast this against the prototype, or typical domain-driven design thing, for example, you wouldn't, for example, use an effect for a user repository or something like that. Yeah,
clearly not.
No. So the effect would more be I don't know, at the IO level.
Yes.
For example.
IO is a perfect effect. Yeah, totally.
Okay.
And I've written 2 blog posts on the subject that we can link to later.
Yes,
because I went that route. I wrote a full application with this in mind, and then I realized that this is not what I wanted to do. That did not give me the flexibility I was expecting.
Yeah. I think, and I guess that's always like kind of a trade-off, like how big the interfaces should be, because if you have like a small, if you want to have like a separate interface for each concern, you sort of get this fractal of different interfaces, and that's like, that's can be hard to deal with.
Well, there's another reason is that it really breaks encapsulation actually, because if you have a function that has a user repository effect, uh, so internally it's using a user repository, but you as a client of that function, you don't want to know how things are persisted, where they are persisted, whatever. But now it's right in your face that this function is using a user repository. So in practice, all those effects, they kind of bubble up and they show up everywhere. But those
Yeah.
are implementation details. You should not have to see them.
Yeah, I see. Yeah, I guess you sort of get locked into a very specific pattern of like, this operation has to be done exactly this way, even though you don't really care about it. But I guess this brings us into like a different, like a related topic as well, because testing, because Unison has its own way of testing things as well, as
Yes,
far as I understand.
which is great.
Yeah.
I really love it. I really like it because it does a few things that I really like. So
Okay, tell me.
the first one is that you have the concept in Unison of watches, which is a bit like integrated REPL. So if you start a line with a greater than sign, it's like a REPL sign, but it's inside your editor. It's going to evaluate any code you put on that line, right?
Oh,
So
okay.
effectively, the REPL is integrated into your editor, which I think is great. I mean, I came to love REPLs, as a way to experiment with code and so on.
Yeah.
And the second thing is that now if you put test and then greater than, it executes a test. So you can
Oh,
put
okay.
test in your code like that.
Yeah.
And there are a bunch of, so there's a testing library. And the thing that I really like about that testing library is that you can do unit tests to property-based tests in a very seamless way. You can start with a simple unit test with, you go test.verify, and then you write your code, and then you decide, oh, but I would like to generate some data for this.
Yeah.
And then inside the body of that test, now you can call an ability that's going to generate a different data using the random ability to generate random data, and running your test 100 times with the each ability to do the same thing 100 times. And now you have a property-based test. And it was the same simple test that you can evolve to be more sophisticated and deal with more cases by just changing a few things. So I really like this. And the next thing that is really great is that once you've written a test, because everything is hashed, if you have some new code that does not touch this test, the UCM, the Unison Code Manager, is able to detect that, and it will report that all your tests are green because they are cached. You didn't need to run them again, so no time is spent running the same thing over and over. You just run the tests that make a difference.
Yeah, that's very sounds great, I think. So it's like, you get like dependency tracking for free, like as part of the test suite. Speaking of testing, I like there's some special tools in Unison for documentation as well, right?
Yes. So again, sometimes the first time I discovered Unison, I thought, oh, it's actually my dream come true. Because, I've always regretted that when I was writing documentation, the thing was not, type checked. So you change a piece of code and then your documentation becomes obsolete. And the refactoring tools, they don't know about the documentation. It's very frustrating. And sometimes, I mean, if you take the old Java documentation, there was no real markdown, so it was hard to
Oh
restyle
yeah.
properly. So yeah, Unison fixes all this. So the Unison documentation has some markdown syntax, so you can use tables, bullet points, italics, whatever. And also it is type checked, so you can put some code inside, and if you change a function name, now you will get the new function name if you ever change that function. And it's also executable. So you can put examples right in your documentation, and then we can see the user can see the result of calling a given function, for example. So I think it's really fantastic for documenting anything. And not only that, but you can grab your documentation term as a Unison term, and you can access the doc AST.
Oh,
So
okay.
you can do stuff with it. So, for example, I implemented a command line options parsing library where you can document all your options as a piece of doc. And so usually the doc is interpreted as HTML, but I was able to take the same thing and now interpret it as some ASCII text in a terminal.
Ah, nice. So you can get you can use the same source for generating documentation and also the same source for getting help output in the terminal.
Exactly,
Ah, that's
exactly.
very cool.
Yeah.
Very nice. Yeah, it seems like a lot of things in Unison are super well designed.
Yes,
It
yes.
seems
I think that comes from people who are really frustrated about lots of things and decided to fix them. Yeah.
yeah. I mean, speaking of another, if we circle back to the things that I said, were annoying to me, one bugbear is the serialization. Because it feels like a lot of my daily work is just writing serializers and deserializers. But in Unison, when you have I mean, okay, so I guess maybe my first question should be how does it work when you have several Unison services that are supposed to communicate with each other?
Okay. So services in Unison are just Unison functions. So you just call a function that happens to be executed somewhere else. So that's fine. But that being said, you still need sometimes to communicate with services that are not written in Unison. So you might have to call some REST API for Stripe, or in my case, when I was experimenting with all of this, I was calling my bank to get all my transactions from my bank account. So in that case, you need some JSON to serialize the code back and forth. And one thing that's kind of it's actually an interesting point, I think. So in many programming languages nowadays, you use some meta programming to do this. So you have a data model and you put some kind of annotations. So in Rust, for example, you have annotations where you say, okay, now I want this data structure to be serialized to JSON, or being able to be deserialized from JSON. And this attribute should map exactly to this name because I want underscores to be translated to dashes and things like that. And those things can be pretty elaborate. And in my experience, many of those things fall short. In real life systems, anytime your protocol, your serialization evolves,
Ah,
it
okay.
becomes very difficult to maintain anything once your protocol evolves, because you have one data model with one set of annotations now that needs to map to different things. And that can make your life really complicated. I had an example like this in Rust, for example, where we had a data model that we wanted to serialize to two different serialization backends. One was, I think, CBOR, the other one was JSON, actually. And the same attribute was not controlling for exactly the same way things should be serialized.
Ah, okay.
And it was unsolvable. We had either wrong JSON or wrong CBOR.
Yeah. Okay, so in this case, you would say it's actually better to sort of write your own serialization and logic
So
by hand, so you can sort of control exactly how it behaves.
So that was exactly my approach in Haskell. I was still able to use some macros to minimize the amount of things that had to be written by hand. But in both Haskell and Unison, I implemented some libraries where when you have a change in the protocol format, you can describe encoders and decoders so that you can say, okay, now for that new format, I want to take the exact same of a set of encoders and decoders, but just change one decoder. Now it's going to decode something slightly differently to my my updated data model. And this is how I handled those things. And it was specifically really important in my case because I was working with a ledger system where we were putting some information on a ledger and forever, basically. Some transactions that will stay there forever. The system evolves, the data model evolves, but you still need to be able to read what was written there like 3 years ago.
Ah, yeah.
And we had 14 versions of our protocol, right?
Yep. Yeah, yeah. Then it's like, I think that's a really difficult problem, actually. Like that whole, and I think it feels like you're getting at something that's a bit, again, almost like a philosophical problem, because like, especially when you have something that is strongly typed, it's like a type is sort of a statement that is valid at a certain point in time. Like type systems don't really take time or change into account, at least not any of them that I know of. But the problem with like you said, like data is sort of like a continuous stream of information.
Yes.
Like it's sort of a series of statements that, like, they're all true at the same time. And like, getting this into fitting this into a type or fitting this into the serializer can be really difficult.
But the cool thing I realized at the time, which for me was a great insight, is that it is the same problem as the dependency injection problem. You have a graph of things, like a graph of related types, and at some stage you want to replace one edge of that graph with something else. So in dependency injection, you have a graph of components, and in some places in your graph, you want to replace one component with another. In a graph of encoders, or decoders, you want to replace one decoder with something else to be able to read that previous version. It's the same problem.
Ah, yeah, that's true. That's interesting. So it's you sort of you're thinking that, like, it's sort of like same way like the data sort of evolves, and like, there could be graphs and subgraphs, etc., that are the same, and then you sort of like, you can sort of evolve this graph over time.
Exactly.
Like, okay.
And describe the evolution as graph transformations.
Oh yeah, that's very interesting. It's sort of like one thing that I think is kind of like underappreciated, like when you think about like database systems, for example, is that, like, I think a very, very elegant thing in like databases is the fact that schema changes are also part of the event log. So it's not just like, I mean, naturally you would think that like all the destructive or side effectful operations should be in the event log, of course, like updates, deletes, etc. And I think everyone who is familiar with event sourcing will recognize this idea, or like, event-driven systems in general. But I think the clever thing about like database systems is that schema changes are also part of the same event log. So, and which kind of leads me into the whole thing about Unison persistence. Because as you mentioned before, another thing that Unison can do is to sort of save Unison terms to a permanent memory.
Yes.
Which sounds really, really cool, because, that's also another thing that's like, dealing with databases and persistence. It's usually not a good time. But how does that work? Like, can you just take any Unison value and sort of say, oh, save this?
Yes. So the answer is yes. I don't really know about all the details. What I know is that so there's a concept called an order table. So when you persist anything, you need to be able to serialize it. So that's a given in Unison. But you also need to be able to key it, to give it a key, to be able to select it later
get it
on,
back
right?
later.
So the another table allows you basically to define keys and values, and eventually that's serialized to a DynamoDB database at the moment. those things, as far as I know.
Okay.
And the whole question is, okay, how can you then structure all of this so that retrieving information, joining it, becomes efficient? So I don't know exactly about the nitty-gritty details on how they do it. I know that Paul Cusano at the moment is working on a small library to query data as collections. So a bit like Link.
Okay, yeah.
In that sense, and he's I think the library is called Kestrel. So that's ongoing work. But there are already some primitives for retrieving data that you put in an order table. But I don't know exactly how they made it efficient.
Yeah, I think another thing that I've been wondering about is like, okay, so let's say I have a record of type like person or something, and then I persist it. And then later on in an update, I add a field, like let's say, oh, now the person type didn't have an email field before, but now it has an email field. If I persist an old version of that record, and then I try to get it back, what will happen? I don't know if there's a...
So I think they have. I think there's a concept. I think there's a concept of migration where if you want to be able to grab old terms and translate them to new terms, you need to provide a function basically saying how this is going to happen. Otherwise, your new code will only grab new terms that you persisted. But again, unfortunately, that's the part I haven't had enough time to explore. So
yeah, and I've tried to look at the docs. It seems like this is kind of, and I could be wrong about this. Apologies in advance if so, but it looks like this is something that they are still actively working on, as far as I can tell. Because this is a really hard problem. It's it's. But I think here's the thing, like, if there is a system that is able to solve this in an elegant manner, it would be Unison. Because again, here's another thing where you notice how, like, you run into problems with multiple sources of truth. If you have both files and a code base, and this becomes really clear once you start dealing with data, for example. Like,
exactly.
I mean, it feels like every programming language has its own, like, ad hoc migration system for databases, right? Like where you have to sort of, you try to save a bunch of SQL statements that you have, like, that have to be like reapplied in a certain order in order to get your system up and running. And it's like, I don't know, it feels like this is symptomatic of a problem that, or how can I put this? It shows that there's an unsolved problem here, like the fact that we have to sort of keep reinventing this kind of like, SQL migrations thing. And we have to...
And I think Unison also has an edge here because it's old code. Sometimes there are migrations where not only you need to grab the old data to transform it in a new data, but sometimes SQL does not cut it. Sometimes you need some new information to add. For example, you need to take the old data and add a new tenant ID, for example, that wasn't there before, but that comes from another system. And for this, you need some code. And in Unison, this is still some code that can do all of this. That's some code that's going to read the old data, grab it as a term, transform it into a new term, and you stay into the same realm. Whereas if you only have SQL to do those things, it becomes a lot more difficult.
Yeah. I mean, I think everyone, it feels like the first thing that happened after SQL was invented was that people started trying to get rid of it. But it's difficult. It does. I guess this is one thing that shows the strength of the Unix principle. Like SQL, it does information retrieval and persistence, and it does that really well. So it's like hard to get rid of.
There are still people. I think I saw a paper recently of people reinventing SQL and making it almost the same, but by having possibility to change where you put your order, where close, group by, and so on, and that make it a lot more understandable. I think that even if we take just SQL in this kind of current form, there are lots of ways to improve it, because some queries are really hard to write. I don't know. I'm really not an SQL expert, but I remember sometimes spending some time on queries like, okay, how am I going to write this damn thing? Because it's really complicated sometimes, right?
Yeah. I mean, and the thing is, like, it's really hard to. It's kind of awkward to compose as well, because basically, I mean, you're lacking one of the core building blocks of composable systems. The functions.
Yes, exactly.
And I mean, there are ways to compose SQL. For example, like, you can have views, for example, and that actually works quite well, because, like, if you think about it, it's all just sets, right? So, like, you can always get a new set by, like, taking the like union or the intersection of two sets, etc. But I mean, sometimes you really want functions, and you want to be able to do, like, I mean, there's a lot of, like, data manipulation stuff that's hard to do in SQL, that's trivial in application code, and vice versa. Like, the best in the best of all possible worlds, it would be would be able to bridge this gap somehow. But yeah, is there, like, let's say we covered the RPC thing. Is there anything else that you would like to say, like, that you think
I think
that Unison will do, like,
well,
can help with?
something that we haven't covered really, and maybe some functional programmers or Haskell programmers might wonder about, is why don't we have type classes in Unison?
Oh yeah, that's a good question.
And
Why doesn't Unison have type
classes? it's at first it's a bit surprising. And just to take an example, if you want to take any kind of data type and translate it to some text, there's no show type class. So every data type that you create, in general, there's kind of a convention that you have a toText function. So you have nat toText, you have like a float toText, you have local date toText. But there's no thing unifying all those functions where you can say, give me a toText of something. And I think the reason was that the people who created the language, they wanted to keep it simple. And type classes, it's not as simple as it seems. Even in Haskell, they evolved gradually. You had the first introduction of type classes, and then people said, oh, maybe we could have several type parameters and have multi-type parameters type classes in Haskell. And then some people said, yeah, but you could have dependencies between the two types, and one type could actually determine exactly what would be the other type. And the system became more and more complicated on how you select the instances and so on. So the design space is large for type classes. And I understand that they wanted to avoid this, but the thing is that does not exist. So you might think, okay, well, we can just create a toText function and be away with it. But
the OCaml programmers are just nodding along. You're like, yes, of course, that's how you do it.
There are some cases that are more difficult. And one of them is equality. So in Unison, you have the concept of structural equality. So triple equals, and you can grab any values of the same type, and the runtime is able to tell you if those two things are equal, because basically they have the same structure. So you can compare the different cases of an ADT. If it's a record, you can go field by field and check them. And that looks fine. But not always. If you take a data type like maps, for example, two maps that are logically equivalent are not structurally equivalent. It might not be internally represented exactly the same way. So that's pretty problematic, because now you cannot use triple equals reliably to decide the equality of two maps. So you can use the map.eq function that will tell you reliably if two maps are equal, and you think, okay, that's done, I'm good. But you're not done, because now if your map is a field into a larger data model.
Yeah. Oh, it's recursive, of course.
Yeah, you have a product containing, I don't know, an address and whatever, and inside there's a map. Now, if you want
Oh
to compare
no.
two orders using triple equal, it's always going to fail.
Yeah.
So eventually, what that means is that you have to have a nice way to implement equal functions by hand. And again, building on this idea of dependency injection, I created a small library where you could do this. You could have some
Ah,
primitives
cool.
to easily create equality instances that you can reuse. And the cool thing about dependency injection is that you can say that you can slightly change the meaning of equality if needed. And that can be very useful for tests, for example. So if for tests you have a large data structure and you want to say, okay, I don't want to compare the dates because those are timestamps that are going to be arbitrary, and it's going to be difficult for me to put the exact timestamps everywhere. And I won't say, now take this same notion of equality for this large data model, but for everything that is a timestamp, you consider that it's equal.
Ah, that's cool.
And you
Yeah.
can do this.
Because this is a common problem. Like you always have to like go in and like instrument, like in testing, you always have to instrument everything that's like source of non-determinism if you
Yes.
want to use the, or like painfully try to destructure things and like compare everything that should be equal, etc. But yeah, all of those are a lot of work. But in this case, you could like do a custom equality
Yes.
for a.
Yes. So there might be, I mean, I know they are still considering it for some future, but it's not in the near-term roadmap.
But I think that and a solution I've seen in some Unison code that I have looked at is basically taking the idea from Gabriela Gonzalez Scrap Your Type Classes blog post, right?
Yeah.
Where you sort of like, or could you describe the idea behind that?
If I remember correctly, the idea was just to do pass them around as parameters.
Yeah, it's like the because I mean Haskell type classes under the hood, it's compiles down to a dictionary of
Absolutely.
functions,
Yes.
so you can actually do the same thing,
Yes.
and it's quite neat as well because you can have you can parameterize these records as well. Like
Yes.
a record can have like a type parameter, for example. So you can say that okay, this I don't need to define like a record for every type. I can define a record for like equality, for example, and it says that like okay, it might need to implement or like equalities might be a bad example, but I mean to text, for example. Or something like comparison, like I might need to implement two operators, and then that's a record that's parameterized over the type I want to implement comparisons for. So I don't know, it's like it's not that bad in practice, I would
Well,
say.
one big sadness I have about Haskell is that there was a paper and an actual implementation. I think it was in 2018, maybe 17, something called explicit dictionary application and consistent as well. So they were proving that the system was consistent, where you could have Haskell functions that would take type class constraints, and you can inject your own dictionary of that type
Oh,
class inside as you could provide the instance yourself when it was required.
okay.
And they had a full working prototype of GHC with this. They proved that this has like some nice consistency properties, but the thing was never transformed into a production feature of GHC, unfortunately. And then the researchers, they went on doing some other things.
Yeah. Okay. That's a shame. Like that's yeah, because that's then you could do the thing you described. Like you could swap out
Exactly.
behavior, like dynamically without having to do like a bunch of. I guess
I
you'd have.
think
Yeah.
there is a crazy implementation by Ed Kmet. I think it's called in the reflection package or something that more or less does the same thing, but in a much more complicated way.
Okay. Yeah, but that would be quite interesting, I think. Yeah, so like, but also operator, I think, or how does it work with like operator overloading in Unison? For example, if I want to have my own, what would you call it, like a plus operator that works for multiple types, etc.
So it doesn't. So you can still call something plus and have my data type dot plus, and then it's up to you scoping the imports properly to avoid conflicts. So if you say, so the way you import something in Unison is by there's a keyword called use. So you say use my data type dot plus, and then you can use plus. And if the two sides are your data type, it's going to be fine, and then you can use plus. But it's really the plus function from my data type. It's not an overloaded plus function.
Yeah. It's like some people code like that in F# as well. Like I code a lot of F#, and like it doesn't have. I mean, it kind of supports operator overloading, like kind of restricted form of it, at least. But I notice some people, they like to do that thing as well. Like, you know, they and I guess OCaml does this as like I see OCaml programmers do this as well, I think. Where, like you said, like if you want the plus, like custom plus operator, you define plus or plus plus or whatever in that scope for a like particular type. Then that's. But would you say this is like a huge trade-off, or is it worse? Is it worse than it's, or maybe it's not as bad as it seems?
Well, yeah, it's not that bad as it seems, I think. I think the equality problem is a bit of a problem because that means that you have to write your own equality functions, and that's always some boilerplate. Sometimes you wish you had like a generic show, type class to just be able to say take anything and not be able to show it. So there is a bit, there is something called to debug text. There's a function that does this.
Okay. It takes a shortcut.
Yeah, that function is implemented by the runtime and has some issues. If I remember correctly, if you have some code that implies some I/O in some context, you cannot use that function. There's going to be a runtime error, so it does not always work. So it's kind of unsafe to use that function. So yeah, I think it's a minor thing. It's not a big thing. It's a minor thing. The thing that I would like to have most is actually coming up is a better record system.
Okay, tell me about that.
Yeah, so when you have data types at the moment, when you define fields, automatically the code manager creates accessor functions for those fields. So for each field, you have a function to retrieve the value called just the field name, a function to modify it called .modify, and a function to set it to a new value, .set. So three functions for any given field are created automatically for you, which is nice.
Yeah.
But once you decide to delete that field, then you need to delete those functions too. So it's annoying to every time you refactor your domain model, you have to take all those functions. Maybe their automatic implementation does not compile anymore. And then you have to mark them as to do delete and later on delete them manually. So at the moment this is not convenient. That's because records are not real first class entities. But that's coming up. That should be, yeah.
Okay, so basically it's sort of like Haskell, I guess, in that regard. That like it's sort of under the hood, it generates functions to like access and manipulate record fields.
Exactly.
But you're saying that like if you delete the record or the field, those functions don't get removed automatically.
Yes. Yeah.
Yeah, I can see how that would be annoying. Yes.
It is.
Yeah. I mean, I think Unison. It seems like it has a pretty good like power to weight ratio in the type system, because, like you said, like type classes, it is a complicated thing. And I mean, Elm, for example, doesn't have type classes either, and I guess it's because of a lot of the same reasons.
Yeah, you can imagine all the changes to the syntax, for example, that will have to happen to mark, type class constraints in addition to abilities constraints, and that's going to make the whole language a lot more complicated. So in a way, I really like the fact that it's as simple as it can be and still do powerful things.
Yeah, I mean, compared to like Haskell or Scala, for that matter, it's
Yeah.
quite simple.
Actually, the thing that maybe that I'm hoping for is to have a better, so people have been talking about a code-based ability. So the ability to grab your code and modify it with some Unison code. So
Oh,
I mean, all those instances for equality, show instance, whatever, if you had the means to produce them with some code as a macro system, that wouldn't be that bad. And this
yeah,
is
that's
something
interesting.
we can think about.
Okay, so yeah, that would be sort of like template Haskell, I guess, in a
Yes,
way. Or
yes,
like, yeah, Scala has Scala macros as well.
yeah,
Yeah, I mean, that could be a good, like an elegant way around this problem, I guess.
yeah.
And isn't that how like Rust kind of works as well? I mean, Rust does have traits, I guess, but for
So
some of this.
Rust has macros, but they are very low level. So basically, you're manipulating tokens that are like individual syntactic elements. You don't know if the thing you are going to produce is even going to compile, or if it even makes sense. So there are libraries in Rust to help you produce some code that is probably going to make sense, but the original macro system, I'm not really a Rust expert in that sense, but yeah, the original macro system is very low level. Scala, for example, has a much more elaborate macro system.
Yeah, and they changed that in Scala 3 as well, right?
Yeah, they made it more robust. Yeah, they
Okay,
changed it
okay.
completely. They rewrote it, and I mean, I had a bunch of Scala code depending on the old system, so I had to rewrite all my code. So I know about that. Another
Yeah.
thing I forgot to mention in Unison that is actually quite cool is you have rewrite rules inside the language. You can write code that will structurally match some existing code, and that will rewrite it differently.
Oh, really?
Yeah.
Okay.
So that can be useful to if you know some transformations that need to be correct, and they all have the same shape. You can write a rewrite rule that will do this for you.
Oh, okay, okay. So, and how do you define these rewrite rules?
Some sort of pattern matching. You say every time I have a term that looks like the addition of two naturals together, replace it with some multiplication, for example.
Okay, okay. That's interesting. So, like, I mean, just to give the listeners some idea of what you could use this for. For example, in Haskell, there's an interesting thing called like stream fusion. I think, or at least I think it's called stream fusion, where you sort of like if you have, I don't know, let's say you have two map functions over a list that the map functions run in series. I mean, under the hood, it would first create one list with the result of the first map function, and then it would create another list with the result of the second map function. But using rewrite rules, like you can merge this. So instead of iterating through the same list twice, just apply the first mapping function with the second one, and then it just does one pass through a
Mhm.
list. And you're saying you could do something like this in Unison as well?
Yes, but it's even better because then it will be properly type checked because in Haskell it's all in comments. The
Oh yeah,
rewrite
yeah,
rule
that.
is pure text.
Yeah, yeah. Okay, so so it's even more powerful. Yeah, because the Haskell stuff it's pretty like just it's basically like pragmas, right?
Yeah, exactly.
Okay, okay. Yeah, that's very cool. But have you used them in any of your
No, I
libraries?
haven't
Okay.
yet. No, I've tried it just to see to play with the example, but I haven't used it yet. No.
Mm. Yeah, because that's like very very powerful and flexible thing, I guess. So
Yeah, I have
yeah.
used LLMs to produce some code and or try to change some code, and that worked more or less okay.
Mm. Yeah. I mean, I don't know. I think we're starting to run out of time, so maybe we should start wrapping up.
Sure,
But
sure.
I mean, before we do, I just want to ask you, Eric, like, what do you think is like the future of Unison?
Uh, um, I think it will all depend on a bunch of companies willing to bet on it. As you know, any kind of new technology, it's very different from many things, and it has lots of potential to help you develop, microservices and be very flexible and very fast to deploy something you need. But you need to believe in it. You need to
Mm.
believe that the team can deliver and that your developers will get up to speed with it and so on. Um, so I don't know. It's you need to find a bunch of companies that are willing to bet that what they build that this will give them such a big competitive advantage that it's worth trying out.
Mm.
Uh, if that works, because the funding of the Unison is they are funded by a foundation, so it's a non-profit language.
Ah,
The-
okay. Yeah, the Unison Foundation, right?
yeah, the only thing they want funding coming from customers just to be able to develop more of the language, more libraries, more support, and so on. So this will only work if some companies are willing to try it out and rely on that for their
Mm.
own developments.
Yeah, and I mean the I think it feels like the like you said, it's companies will have to be there has to be companies that are willing to bet money on Unison,
Yeah.
and it feels like on one hand like it's a bit tough because Unison is so different in many ways, but on the other hand, it's like Unison actually does solve real problems. I mean, this is not just some like ivory tower speculation like thing like, oh, we should like I don't know, programs should be more type safe, or like we should use this really super advanced type theory. I mean, Unison is solving real pain points. Like I mean, uh, all of the things you said uh, today on the podcast, like how you don't need to bother with like too much with serialization. This serialization, the language supports persistence. You can deploy things like really quickly and conveniently.
So
Like,
yeah, typically I see some companies using Python for this. So they start by prototyping some stuff for their business, and they reach for Python because they think, oh, dynamic language, that should get me there faster. But they might still have all those serialization issues, persistence issues, whatever. And I'm thinking for those companies, maybe they should use Unison. They've deployed their services a lot faster, not have to worry about infrastructure. They can just focus on their business logic, and maybe if they want to later, they can move to a different, stack, use Go, whatever. And for lots of prototyping of new startups, of new services, I think actually Unison could be a great bet.
yeah, because it's like especially when you're working at this kind of scale. I mean, usually when it breaks down, it's all of these things when services are supposed to communicate with each other, and there's usually a lot of like inefficiencies where you sort of have to very carefully decide on like a common protocol, like design all of this. You have this really long meetings where you decide on exactly what the REST interface is supposed to look like so the teams can communicate, etc. Like with Unison, it's just like, yeah, well, it's all Unison. It's all, if it compiles, it works.
Yeah.
Uh,
And another use case might be all the people writing Lambda functions using AWS.
mm,
Lambda functions are actually hard to write, deploy, test. They might just use Unison if they have just one function they want to write and deploy. It's a lot easier to do with Unison.
yeah, yeah. Yeah, exactly. Like, and then you can host all the infrastructure yourself, etc.
Yeah.
One thing I was curious about is like how, and I mean, I guess this is like an unexplored question, but let's say you have a really large team of programmers.
Mhm.
Would it be better to have all of them targeting the same like Unison code database? Like, or should they have like different, split it up into, I don't know, separate Unison services? Or I don't know, maybe that question doesn't even make sense.
Well, in a way, you would I think that's a cool thing. You can attack this problem as a monorepo problem, and
Hmm.
but you can still deal with libraries and split your code base into several libraries that make sense to version independently, knowing that you will not never break all code, which is kind of cool.
Yeah. Yeah, because you get rid of a bunch of the different. I guess we're sort of getting into unexplored territory here, but I guess in theory you could just like keep all of the code in the same uh, repo, because basically you don't like deploying new code is not as disruptive
Mm.
as in a regular code base where you sort of have
Yeah.
to merge a whole bunch of things. You could just like I don't know, at least it feels like it would be much easier to patch a big Unison code base
Yeah, and
incrementally.
one thing I didn't mention, for example, is you don't really have the diamond problem, so you have library A depending on B and C, and B and C depend on D, but then B decides to take another version of D, and then it breaks for
Ah,
C, you see? This is a real problem. In Unison, you never have this, so you can upgrade one library that depends on a new version of a dependency, and then the other library will depend on the older version, and that's not going to break anything. Everything will be fine.
yeah. Yeah, that's another thing we didn't even cover, like, how dependencies work in
Yeah.
Unison. But that's just Unison code as well, right? That you can
Mhm.
reference, like, or how does that work?
So if you have a new version of a library that you depend on, you go to Unison Share, you say, uh, you take the version number and you say install it. So you install it locally, the code is downloaded, and then you say now I want to upgrade it. So you select the previous version. You say now I want it to be upgraded to the new version. But the thing you are installing might depend on some other things that are new.
Hmm.
But it's just going to reference those other things. It's not going to break any other library that you depend on,
Hmm.
because they will depend on copies of, the older versions of those updated versions. So you're never breaking anything. The thing that might be weird and sometimes a bit puzzling is that because the names now might be different.
Hmm. Yeah.
So
Yeah.
the older version of something might end up in the code just as a hash, because
Yeah.
now a name will reference the latest version.
Hmm.
And so you still need to be able to represent an older version. In that case, when you display the code, you will see the real hash instead of the name. So at first you will not recognize what was this function
Yeah.
because it's a hash. um, so yeah, but again, I think it's mostly a matter of tooling. Instead of
Hmm.
displaying the hash, we could also display the old name and like a tag saying, okay, this was the older version of that name.
Oh yeah, that's a really good use case for like being able to like attach tags to sort of like a top level hash or something. Because I
Yeah.
mean, essentially, it's the same problem as in Git, right? Like like a branch only ever
Exactly.
points to one hash. Like, and if you check out an older hash, like, that's just not the branch anymore. That's just the
Yeah.
hash.
Yeah.
Uh, yeah, I mean that's it's really cool. I think we have a really good selling point for the for the Node.js crowd as well. You can get multiple versions without having a Node modules directory that's like several gigabytes of code.
Yeah.
It's like a killer app for the like JavaScript world. But okay, so if people want to learn more about Unison, what's the best way to
The
learn?
Well, there's the website and there are tutorials and so on, but I really encourage people to go to the Discord website, I mean application, and just introduce themselves, and don't hesitate to ask questions. There's also even some pairing channels. Very frequently you have people pairing in video trying to solve something.
Cool.
Which is also a nice way to learn about Unison.
Yeah. Because I mean, this is it is really like, you know, bleeding edge technology in multiple ways. I think. I mean, not just because it's a new programming language, but it's like, you know, the whole paradigm is quite.
Yes. And also, one thing that personally attracted me to Unison was the community. I knew several members of the team, and they are all super nice and super friendly. And you feel really welcome when you arrive in the ecosystem. So this is great.
Oh, that's good. That's perfect. Yeah. And where can people find you, Eric?
Well, nowadays it's LinkedIn, X, GitHub. My handle is always the same. It's Torreborre, Eric Torreborre. So it should not be too hard to find on the internet.
Yeah, and also you have a very nice blog. I think that I have enjoyed reading, and it's, you know, on a large variety of topics, and you have several interesting talks as well that I recommend people check out. So.
Yep, absolutely.
Yeah, or almost like you're kind of an influencer as well.
Well, no, I wouldn't go that far, but honestly. I have other rants, maybe if you read my blog, about not being very much a techno-optimist, which in a way sets me apart from the crowd. Something I like to talk about as well.
I really like that you have a very interesting blog post about concurrency as well. I think the one where like you sort of the one about actors and
yes, it's it's not a definitive opinion on the subject. It's more something that feels troubling to me. I like how much functional programming is putting things on rail that really allow you to think about what the system is doing step after step. Whereas with actors, it feels like sometimes all the behavior is really emergent. You send a message, you don't know what's going on, no response, maybe it's spawning another actor. And I've worked with some actor systems that were really hard to debug, understand, because it was hard to make a mental picture of what was going on there. And at the same time, people are building very successful systems with actors. So why? How come? And because I think there are also some nice properties to actors, like that are very simple. The simple threaded way of dealing with, well-ordered events in your own, isolated world. That's great. The fact that you mess up your own state, you don't mess up the rest of the state of the system. That's also great. I think actors are more like a design pattern to reach for in some certain situations. And it's just like trying to use them all over the place might not be a good idea.
Yeah. It's not definitely not a silver bullet. It feels sort of like pointers, in manual memory management. It's like, it's very powerful, but it's also kind of opaque. Can be really hard to reason about what's going on, even though the model conceptually is quite simple. But okay, that's I think that's it for this episode. I want to say a big thank you to Eric for
great talking to you
for coming on the podcast. Maybe we can do this again sometime and talk about something else other than Unison.
Yeah.
But yes, talk to you later.